Okay.
Uh, that's where I have no idea what the teacher wants because that's kind of unreasonable. The more likely options are that it goes up forever, or if it were to come back down, it would go down forever. That's what's possible with a polynomial.
Okay.
So, uh, what do you think we should do?
Um, mm, I feel like it doesn't matter because like
Okay,
none of them can be reasonable because they can't go down forever and they can't go up forever. So
that's right. And so actually it does say down here, state the practical domain of your graph. That kind of helps that maybe it could come back down to the
okay.
ground. Because I guess, I guess, I don't know, the teacher didn't really, um, I don't know, maybe it ends like, I mean, roller coasters start and end in the same place. I know I'm getting too involved into this, but I
Yeah, I
mean,
think that what she means by the practical domain, like I don't think the graph, like the ending of the graph has to be practical, but when you're
okay.
doing a practical domain, the ending should be like where it starts, like about.
So that's also reasonable to me, is that, it comes back up, there it is at 250. So, something like that. So, um, um, so let's just, with these things, you got to make sure you've got all the things. So three relative mins and maxes. So we got one, two, three of that, 4 minutes long. So from here to here, we'll get to that part. It's got to be 4 minutes. So I'm gonna go. To me, that's weird. I guess I would convert that to seconds. I mean, I would just have this would be 240 seconds, but that's me. I mean, we can do that here in minutes.
Mhm.
Do you want to stick to minutes or do you want to do seconds?
Um, could do seconds.
All right, well, we'll see what it looks like. We're gonna do this in Desmos, think back and look it up by hand. Starts at 250 feet and then um goes down into a tunnel. So it goes down into a tunnel and then one repeated zero. There's the repeated zero. So I feel like that's reasonable. Do you feel like that meets the requirements?
Yeah.
This picture. Okay. All right. So uh the it says at least 4 minutes long, or is it exactly 4 minutes? At least 4 minutes. Okay. So let's go. This is where I rather do the seconds. So let's go 60, 120, 180, something like that. Is that kind of okay?
Yeah.
Now in red, I'm going to show in red kind of what the polynomial will look like. Probably it's going to be, and it's going to follow it as well, but it's going to go on forever.
Hmm.
So the idea is that this is an odd degree polynomial,
Okay.
but we're gonna see that from this stuff as well. Okay. Any questions before we go to Desmos to graph this to kind of do the rest of it?
No.
Okay. All right. New share. All right. So first thing is you put in the zeros. And the reason that one is squared is because it's going to touch there. And then I got to go out to 240 on that. Zero. Wow, that's really, really crazy. Okay. So we got issue. We need to add a zero over here. Sorry, you can't see that. We need to add a zero over here to the left so that it comes back down, even though you can see that it doesn't. So I'm going to add that one at like -60, -120, something like that.
Okay.
And you'll see that, well, it doesn't really scale well. Maybe that's why your teacher wanted to do this in minutes, because the numbers get so large here. So let me go back and make this 1, 2, 3, and then 1, and our scaling won't be so bad. Okay, that looks better. Does that look okay to you?
Yeah.
Kind of. All right. So the next thing here is that the y-intercept, let me scale this a little bit better. Oh, and actually, sorry, we should change this domain from 0 to like 5 and then see what happens here. So you can kind of see that we have an issue here at the beginning. It's not high enough, and that comes from we need to basically multiply the we need an A. Let me put an A out here. So we're gonna add an A. So if I make A bigger, you can see that this thing jumps up to, it starts really moving up here. Let me scale this better. Sorry. 0 to 5. Let's go -10 to 100. Let's go 500. Let's go 300. Okay. So we have kind of a problem. So this right here, you can see like when A is 6.2, we get whatever this number is here, which it's not defined. But
Mm-hmm.
to calculate it, what you're doing is you're taking 1 times -1 times -2 times 9, and we want to get to 250. So 250 divided by 1 times -1 times -2 times 9. And you can see there that it starts at, excuse me, at that right there.
Okay.
All right. So one of the things I'm noticing, which um, you can see here out at 4 seconds, it's ending way higher. So we really kind of want the graph to come back down over here.
Mm-hmm.
So we might actually add another 0 to it. Maybe so that the graph actually turns down this way to the right. So we can do that by adding in like an x minus 5. Uh, that's not far enough out. Huh. So that we gotta, so our A value is going to change as well. So let me do this too. So if we put a -5 there, now we've got to deal with that here, times -5. So you can see now it doesn't quite end where it started.
Mm-hmm.
So that's kind of an issue here. Like, do we want it to end? Maybe ending at 5 is better, because then we kind of get it to now get it to start and stop at the same place. Um, we can do, but it's going to be a little bit harder. So what do you want to do here? You can see like it starts at 250, but it ends over here on the ground. You think that would be acceptable?
Um, I feel like it would.
'Cause we can also push these x-intercepts out to the right to get the behavior that we're looking for, that it comes back up as well.
Okay.
What would you? It's up to you. Like I don't care. Like these are this is kind of
Mm-hmm.
what they're wanting you to do, kind of play around with it and stuff.
Um, I would say maybe like a little bit higher,
What do you
probably.
mean? What do you mean by a little bit higher? Like, do you want it to not end here, or do you want it to end where it started?
Like and like kind of close to where it started.
Okay, so to do that, I'm gonna remove that. I'm gonna remove that, and you can see that if we need to push everything kind of out to the right. So I'm going to go I'm going to go 2. Sorry, that was the wrong one. I'm going to push each of these out 1, which should do it for us. And so we can go 2, 3, 4. And then we do have to change this one. So it's -2, -3, 16. So we're still having this problem here. We'll just make it go out further. So notice if we let this go out 6 seconds,
Mm-hmm.
it gets us way too far. So we basically got to figure out where to cut it off now. So if we do a y = 250 and we say, okay, let's cut it off at 5.372 seconds. Now you can see it starts and stops at the same place.
Okay.
All right. So like this is it. We've got it,
Mm-hmm.
if that's okay.
Yeah.
And then we'll talk about what to do from here. I mean, this is not the prettiest one. This is, I mean, would this actually work in real life? No, you'd be going too fast. You'd probably jump off the track here, and this would be kind of crazy. But that is not what it's asking for. Do you feel like this would be acceptable to your instructor?
Yes.
Okay. All right. So let me grab some snips, and then we'll talk about what to do next. All right, back to the other screen now, and we'll just kind of start going through what it's asking for. So number one is kind of this one up here. This, I feel
Mm-hmm.
like that is, something like that is what you want.
Yeah.
List all the zeros of your polynomial. So we ended up pushing these out, and we even added one. So um, the zeros are at where this is equal to 0. They're the zeros. This is number 2. They're at -1, 2, 3, and 4. 4 is twice. That's for number 2.
Okay.
Now you can't see the one at -1 because I restricted the domain,
Mm-hmm.
but that it's still a 0 of the polynomial. Although it's not in the domain, so it's kind of a weird thing. I'm not really, it was so not, I'm sort of going back and forth how I think about this because if they're not in the domain, they're not zeros, but they're required to get this picture. So I don't really know what the instructor wants. Um, I think they want it though. I'll just say that. All
Yeah.
right, so the factored form. So the complete factored form, that's what was actually up here. The A is this messed up thing here. The A ends up being 2 times 3 times 16. So it's like 250 over 96, which is 125 over 48. So it's 125 over 48, x plus 1, x minus 2, x minus 3, x minus 4 squared. And that's exactly what we had in the that's exactly what happened there in the decimal. So that's number 3. Oh, it says to show the A value. Sorry, I guess we should do that. So this is not going to work. Well, this is the final answer. How do I want to do this? Okay. So your P of X is A times this. P of 0 equals 250, which is A 0 plus 1, 0 minus 2, 0 minus 3, 0 minus 4 squared. And so your A is 250 divided by 96, which is 125 over 48. So your P of X is equal to 125 over 48 times all that stuff up here. But they want you to show the work. That's why I'm showing the work.
Okay.
Is that okay?
Yes.
All right. 4, I mean, so 4 is awful. It says to show your work. So, I mean, I can just get you the answer. Do you want like to see the steps?
Um, yeah, could I see the steps?
Okay. Um, you got to FOIL this. So x squared minus x minus 2, x minus 3, and then this is x squared minus 8x plus 16. And then you have to multiply these together. So this is it's just bad. You end up getting x cubed minus x squared minus 2x plus minus 3x squared plus 3x plus 6. That's the middle one. So you got x cubed plus 2x squared plus x plus 6 times x squared minus 8x plus 16. I'm possibly going to make a mistake. So that's why I was going to just go to like a Wolfram or Mathway, and you can get to work this out because it's very easy to make mistakes in this. So
Mm-hmm.
this is x to the 5th minus 8x to the 4th plus 16x cubed plus 2x to the 4th minus 16x cubed plus 32x squared plus x cubed minus 8x squared plus 6x 6x squared minus 48x plus 96. So this becomes x to the 5th minus 6x to the 4th plus x cubed minus 24. No, that's wrong. Minus 30x squared minus 42x plus 96. So what I'd like to do, I'm going to at least check this step in wonderful online calculators here. So give me just a moment to confirm that. All right, x plus 1, x minus 2, x minus 3, x minus 4 squared. All right, let's see what they say. X to the 5th. So I did make a mistake somewhere. A lot of places. Okay, I don't know. I made some mistakes. That's the problem with this. X squared minus x minus 2, x minus 3, x squared minus 8x plus 16, x cubed. Do you want me to find the mistake?
Yeah.
Okay. All right, so x cubed minus, what am I doing here? X cubed minus x squared minus 2x minus 3x squared. There's a mistake. Minus 3x squared plus 3x plus 6. That becomes minus 4x squared. It's negative though. All right. Plus x plus 6. All right. So that messes all of these up. Minus 4 minus 4x to the 4th. Space this whole line is off. That's the issue. All right, let's try that one. Minus 4x to the 4th plus 32x cubed minus 64x squared. All right, and so does that do it? That becomes minus 12x squared, 12x to the 4th. 48, 49. Yep, there, that it probably is it. 49x cubed. And then 66. Yep, that's correct now. and then minus, uh-oh, another error in here. So where does that come from? X cubed, so 6x squared minus 48x. Huh. X cubed minus 8x squared plus 16x. There's the mistake. Minus 32x plus 96. All right. Okay, so that's correct, but then you have to multiply it all times 125 over 48. So you do that at the end because nothing really works out. So it's 125 over 48, x to the fifth, and then you just go to the calculator to get these other ones as fractions. So 125 over 48 times 12. So we get 1 minus 125 over 4x to the fourth plus 6,125 over 48x cubed minus 1,375 over 8x squared minus 250 over 3x plus 250. So there it is in standard form.
Why is that so difficult?
Because it's an unrealistic problem.
Oh, okay. Mm.
I mean, you don't design things like this. This is not how you design things. This is a teacher trying to find something fun to do, and it's not really fun for anyone.
Yeah.
All right. Oh my God. Synthetic division by testing users from number two. Oh my gosh. Uh, wow. All right. So to do number five, this is so garbage. I don't know how many you're supposed to test. I mean, kind of reads all of them. Is that how you read it?
I'm sorry, what was that?
It says perform synthetic division to verify the correctness of your equation by testing your zeros from number two. So you have to use synthetic division on this for
Mm-hmm.
all of the zeros. What do you think about that? You think it's all of them, one of them, some of them?
Um, how can you use synthetic division for
Yeah,
those?
so the way to do it, if you go back and look at our zeros, you put the zero in the box. So in this
Yeah.
case, you put like -1 in the box.
Mm-hmm.
You write the coefficients.
Oh, okay.
So you bring this one down, then you multiply by -1. So you get minus 125 over 48, and then you have to add these together. So I'm going to use a calculator because not that's kind of crazy. Um,
Mm-hmm.
minus 1 over 4 minus 125 over 48 ends up being minus 1625 over 48 times -1 is 1625 over 48. 6125 plus 1625 all over 48 ends up being 3875 over 24 times -1 is minus 3875 over 24. Any mistake here will propagate through the entire problem. Divided by 8 minus 3875 divided by 24. So this ends up being minus 1000 over 3, which ends up being 1000 over 3, which ends up being 750 over 3, which ends up being minus 250, which ends up being 0. So it does work. Do you want us to continue doing the rest of them?
Um,
We probably have time.
sure. Yeah.
Okay. All right. So the next one here to do is 2. So 125 over 48 times 2 is 125 over 24. We're just back to adding these together. Minus 1625 over 48 plus 125 over 24. Minus 1375 over 48. So times 2 is minus 1375 over 24. I really want to do these by hand. I should. So this becomes 2500 over 24. This is 2500 over 12. So being minus 125 times 2 is minus 250. You end up getting a 0 there. So then we do it for 3. Bring the 125 over 48 down. So times 3, 125 over 16. I mean, it's not that bad. It's just, this is, I mean, I mean, a real, doing this in real life, you would write a program to do this. You would never do all these
Yeah.
calculations by hand, but
Mm-hmm.
I don't make the rules. All right. So, and if you really want to check that these are working, you don't want to just start saying, oh, it looks like it works. Because like you saw, you can make mistakes like I did. I kind of knew I was going to because it's just insane to do this by hand. All right, and then 4 we have to do twice. These are just the zeros again. So we got 125 over 48, 125 over 12, and then it becomes um, minus 125 over 12, which ends up being 125 over 3, which ends up being 0. And then you do it one more time for good measure. 125 over 48, 125 over 12, and you end up getting 0. There it is. All right. Number 7, we already have. Let me help you out with that though. So the one I snipped in has the equations and stuff in it. So let me all right, let me snip this in. So the things you're going to want to add here, this is in feet, this is in minutes, this is X, this is P of X. That feels like that's good enough for number 7. Is that okay?
Yes.
All right.
Um,
8.
and
Question?
yes. So when I'm talking about the practical domain, um, for 6, would I just say that it has
Oh,
to,
sorry. I completely skipped over 6. I apologize. Uh, Mostly because I was so distracted by 5. So 6, the end behavior of your roller coaster. So have you guys started using limit notation?
yes, but also when I did part 3, or I think it was part 1, and I was doing the practical domain, she said we didn't have to do it like that, that we just had to like write it out in like words if we wanted to. Like it didn't have to be that complicated as long as like we explained why we chose it.
Okay, so you want to say as X approaches 0, P of X approaches 250. So that's the starting point. And then you would say as x approaches, and we got this number from the graph, it's 5.372. P of x approaches 250, or I don't know if you guys are using arrows or equals, but that's the practical end behavior.
Mm-hmm.
Basically, you're saying it starts at 250, it ends at 250.
Okay.
And that's enough, good enough. I think.
With the oh wait. Wait. Does it say to label like any axis? Oh, that's for
I don't know, feet, X minutes, I don't really know, You could say that's the tunnel. I don't know. It's kind of I mean, tunnels aren't curved, not to that degree, but it's an unrealistic problem anyway. Let me know when we can go to 8.
uh yes.
Okay. All right, so for number 8, the domain is from 0 to 5.372. The way we calculated this 5.372 is we found the intersection of our polynomial and 250 so that it stopped. It stopped at the same height that it started at.
Okay.
The range, practical range. So we did not actually calculate the min. If we go back to the graph, we can get the min. The min is minus 5.44. That's just from the graph. I'm not doing anything special. So the max is where it started, 250. So the range is from minus 5.444 to 250. You might make a note that's its feet. Domain is in minutes.
Okay.
All right, using your graph number 7, color the graph where the polynomial is increasing and red where the polynomial is decreasing. So let me grab another snip of it, but change the color here to something else. Settings. Nobody likes red. Let's go black. All right, grab another snip of this. All right. So it said what color? Blue where it's increasing and red where it's decreasing. So here we go. So red decreasing, it's decreasing, 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 decreasing all the way to about right there. It actually is at 2 point. That's roughly there. It actually is right there. So we gotta show that all the way. But it's decreasing, and then it's decreasing over here, and then in blue, got the increasing. Something like that.
Okay.
Now we have to actually get those points. So I'm going to go back to the graph and get those points for us. That one and that one. All right. So, and I'll do it right on here. So it is decreasing, and it's an open interval this time, 0 to 2.388, comma 3.409 to 4, and then it's increasing in the other interval, 2.388 to 3.409, comma 4 to 5.372.
Okay.
That feels like it is everything.
Yes. Wait, so the min. Oh, wait. Oh, never mind. Okay. So the max would be 250.
Yes, yes, we had it, come down, do some stuff, and then come back up.
Okay.
Which
Okay.
again, super unrealistic. Like this is the worst roller coaster in the world. But that they didn't specify that it had to be any good. It's a
Mm,
you know,
okay. And I'll get like the pictures like in my email, right?
yeah, I'll send this to you right after the lesson, no delay. I want to be
Okay.
done with the day.
Yeah.
So yeah, the instructor probably should have said that it has to get higher than the original height, but
Mm,
that's their fault for not telling you. It's a terrible problem. And like it had good intentions, but
yeah.
uh it's not anyway. Is there anything else you'd like to cover? We got a few minutes left if you would like.
Um, I think that's it. Yeah.
Okay, let me go ahead and stop right here then for today.